Welcome back everyone. In this lesson, we are continuing with Inter-Vlan routing, but now we are using layer 3 switches. If you remember previously, we talked about Inter-Vlan routing using router on a stick. So how does a layer 3 switch manage Inter-Vlan routing? Inter-Vlan routing using router on a stick method is simple to implement for a small to medium-sized organization. However, a large enterprise requires a faster, much more scalable method to provide Inter-Vlan routing. Enterprise campus LANs use layer 3 switches to provide Inter-Vlan routing. Layer 3 switches use hardware-based switching to achieve a higher packet processing rate compared to routers. Layer 3 switches are also commonly implemented in enterprise distribution layer wiring closets. Capabilities of a layer 3 switch include 1. The capability to route from one VLAN to another using multiple SVIs or switched virtual interfaces. Secondly, to convert a layer 2 switch port to a layer 3 interface, that is to take a switch port or access port and make it into a routed port. A routed port is similar to a physical interface on a Cisco IOS router. To provide interface VLAN routing, layer 3 switches uses SVIs. SVIs are configured using the same interface VLAN ID command used to create the management SVI on a layer 2 switch. A layer 3 SVI must be created for each of our routable VLANs. Let's look at this figure. We have a layer 3 switch here, D1, and this layer 3 switch is connected to two VLANs, VLAN 10, where we have PC1, and VLAN 20, where we have PC2. The layer 3 switch will provide inter-VLAN routing between these two hosts. So if you notice here, on this interface of the layer 3 switch, it has this IP address, and on this interface of the layer 3 switch, it has this IP address. And these IP addresses of the particular interface is used as the gateway. These are the steps that you must follow to configure D1 with VLANs and trunking. One is create VLANs. So in this case, there are two VLANs. We have to create VLAN 10 and VLAN 20. The second step is to create the SVI VLAN interfaces. The IP address configured will serve as the default gateway for hosts in the respective VLANs. Step 3 is to configure access port. So you want to assign the appropriate port to the required VLAN. Step 4 is to enable IP routing. To do this, issue the IP routing global configuration command to allow traffic to be exchanged between VLANs 10 and 20. This command must be configured to enable inter-VLAN routing on a layer 3 switch for IPv 4. So if you do step 1, step 2, and step 3, but forget step 4, your inter-VLAN routing will not work. So let's look at it again with examples. So step 1, create VLANs. So we are creating two VLANs here. We are naming those VLANs. Step 2, create the SVI VLAN interface. So here we have interface VLAN 10 that is going to interface with the VLAN 10. And then the IP address for that. And then no shut. Remember, this is to make sure that it is active. And then do the same thing for VLAN 20. Now we have to configure access ports. So here, Gigabit Ethernet 1/0/6. So this is the access port to PC1. So we type switch port mode access, switch port access VLAN 10. Do the same thing to the other interface, which is Gigabit Ethernet 1/0/18, which is the connection or the access port to PC2 in VLAN 20. And then we enable IP routing. Just type IP routing in the global configuration mode. So now that we have done that, I'm sure you have seen that inter-VLAN routing using a layer 3 switch, it's far simpler to configure than a router on a stick method. It is very direct. After the configuration is complete, The configuration can be verified, and it must be verified by testing connectivity between hosts. As you know already, verifying connectivity, you can use ping command. So it is also a good idea to make sure that you know the IP configuration, and you can check this using the ipconfig Windows host command. So if you can ping both PCs successfully, that means that the Inter-Vlan routing is operating. Now let's look at routing on a layer 3 switch. On a layer 3 switch, it can actually route and then exchange routing information if it is connected to another layer 3 device. So if VLANs are to be reachable by other layer 3 devices, then they must be advertised using static or dynamic routing. To enable routing on a layer 3 switch, a routed port must be configured. A routed port is created on a layer 3 switch by disabling the switch port feature on a layer 2 port that is connected to another layer 3 device. Basically, what it means is this. You have a port on the layer 3 switch. If you don't do anything to it, it behaves like a switch port. But now you have to say you are not a switch port anymore. You are going to behave like a router port. So you have to disable the switch port feature on a layer 2 port. Specifically, configuring the no switch port interface configuration command on a layer 2 port converts it into a layer 3 interface. Then the interface can be configured with an IP version 4 configuration to connect to a router or another layer 3 switch. So here, this is what we have previously, right? We have this D1 which is connected to 2 VLANs, and then we have configured Inter-Vlan routing. But what happens if these two PCs in these two different VLANs wants to connect to a service outside, which is in the internet? So this particular layer 3 switch must be able to do routing. And in this example, the layer 3 switch D1 is linked to a router. In this case, routing is using dynamic routing OSPF. For the sake of simplicity, let's assume that all these configurations has been done. We are just going to focus on how we are going to change this port from a switch port to a router port and then enable routing to happen. So these are the steps to follow to configure D1 to route with R1. Configure the routed port, use the no switch port command to convert the port to a routed port and assign an IP address and a subnet mask. Don't forget to enable the port. Enable routing, use the IP routing global configuration command. Configure routing, so use an appropriate routing method. So in this particular example, we are using OSPF. Verify that the routing happened and then verify connectivity. So first, configure the routed port. So we have, if you remember from the topology, that this interface is linked to R1, right? So we give a description, no switch port. So we are saying to this interface, you are no longer a layer 3 switch port. You are going to be configured as a router port. We give it an IP address, a subnet mask, and then we activate it with no shutdown, and then we exit. Step 2 is enabling routing with the IP routing command. And then step 3 is to configure routing. So for this example, is OSPF, so router OSPF 10. And these are the 3 networks that D1 knows. The one that goes to VLAN 10, the one that goes to VLAN 20, and the one that goes to R1. So these 3 are here. Now assuming that R1 is already configured, you would see here, you can see here that the adjacency has been achieved and routing can be done. Now that you have done that, you have to verify whether or not what you did is correct. And the easiest way to verify routing is to look into the routing table. So here, show IP route, and then you will see the routing table. C's are the directly connected networks. O here is the interesting part. This is the path of a remote network that is not directly connected to D1, but it learned about the route or about the network via OSPF advertisement from R1. Once we have verified routing, we can also verify connectivity using the ping command. That is the end of Inter-Vlan routing using layer 3 switches. As you have seen, it is quite straightforward and it is easier than routing on a stick. So try it out, have fun, and I'll see you in the next lesson. Goodbye.